This is Arju here and I welcome you to my channel Mr. Teeth, where your dental concept get dissected. So this is our part 2 video, or we can say the second video of our dental material series. Okay, so in this video we will be discussing with the structure of the matter, general classes of the materials and the principle of adhesion. So this is particularly the second chapter of the Phillips science of dental materials. Okay, so we will be discussing with those points, and those points that I will be discussing in this chapter we have studied it in our intermediate level, okay, or during the preparation of our entrance examination. Okay, so all the things that are present in today's video we have studied it in our chemistry and the physics book. Okay, without delaying much, let's start today's video. So introduction to the atom. Okay, so around 460 BC there was a Greek philosopher named Democritus. Okay, Democritus proposed that all the matter are composed of the individual particle, okay, that are called atoms. Okay, that at that time they named that particle as a atoms. Okay, so atoms means particularly uncuttable. Okay, we can't cut it. Okay, we can't break it. It is unbreakable, uncuttable. And as this is basic of this chapter, this is structure atom. As we all know that atom contain three major components: neutron, proton and electron. Okay, so neutron and the proton are present in the nucleus center of the atom, and electrons revolve around this nucleus in its particular cells in its particular energy level. Okay, so there are particularly three states of matter. Okay, so there's one is solid, another is liquid and another is gas. So solid changes into the liquid, and the energy that requires for the changing of the solid phase to the liquid phase is called latent heat of the fusion, and liquid changes to the gas by the latent heat of the vaporization. Okay, so sometime in a competitive exam they can ask. Okay, and after that I have written here about the sublimation. Sublimation means simply the change of solid directly to the gas. Okay, okay, now in interatomic bonds, okay, we have particularly two forms of bond. One is primary bond and another is a secondary bond. Primary bond are also called chemical bond. Okay, and there are three types: ionic bond, covalent bond and metallic bond. Okay, ionic bond means there is a bonding between the two ions. Okay, so one atom loses the electron, another atom gains the electron and form their particular anions and cations. Okay, gaining of the electron forms a anion and the losing of electron forms the cation. Okay, so in dentistry those ionic bonds are present in the gypsum product, phosphate bonded cements. Okay, like zinc phosphate. Okay, now in the covalent bond, okay, so covalent bond simply there is a sharing of electron between the two elements. Okay, there is particularly the sharing. Okay, there is not a giving or receiving of the electron, just there is a sharing. Okay, and in dentistry the covalent bonds are present in the dental regions. Okay, in dental region there is presence of the covalent bond. And metallic bond, okay, so metallic bond are present in all those metals that are used in the dentistry. So in orthodontic we use different kinds of orthodontic wires. Okay, and also all those things, okay, that we use in a dentistry that is made of metal do have metallic bond. And in secondary bond we have one is van der Waals force, another is a hydrogen bond. Okay, so secondary bond are particularly those type of bond, okay, that are between the two dipoles. Okay, so dipoles means what that when the molecule is formed, okay, when the molecule is formed there is a formation of the positive and the negative charge in that particular molecule itself. Okay, and that act as a dipole. Okay, means having the two poles, one is positive pole, another is a negative pole. Okay, so they act as a dipole and there is a dipole interaction in this secondary bond. Okay, and the example of secondary bond is van der Waals force, and the another is a hydrogen bond. Okay, so now we will discuss about the atomic arrangements in this chapter. So particularly there are two forms of atoms arrangement in the molecule. That is one crystalline structure, crystalline arrangement, or another is non-crystalline. So in crystalline structure, as I have written here, there are 14 possible lattice type. Okay, so there are 14 different types of crystalline arrangement present in any molecule, and that type of space lattice. Okay, so the type of lattice is defined by the length of each of the three unit cell edge and the angle between them. Okay, so I'll show you in the picture. Okay, so I'll take few minutes. Okay, so in this picture as we can see here, so this is a crystal lattice. Okay, and this is a crystal lattice and it is formed by the different unit cell. Okay, so as the cell is our structural unit of our body, okay, similarly the unit cells are the structural unit of any kind of crystal. So in that crystal we can see here a molecule is attached by the three different lines. Okay, so they are called axis or the edges. Okay, and the angle between them is an angle between them. Okay, so that length of that edges and the angle between them defines which type of lattice it is. Okay, so the lattice type is dependent upon that two properties, the length of the each of the edge and the angle between them. After that, most of the metal used in a dentistry belong to the cubic system. Okay, so and all the metal based dental materials are crystalline. Some pure ceramics such as alumina and zirconia core materials are entirely crystalline. Okay, so this we have studied in our intermediate level as a solid state. Okay, so in that chapter we have read it in detail. Okay, so in dental materials we didn't have to focus on those topic much, but for general information we can see once to those topics. Okay, in non-crystalline structure, the best example of this structure, this arrangement is a glass. Okay, so in glass there is a typical non-crystalline solid. It is a typical non-crystalline solid that is arranged of a SiO2. Okay, SiO2 because atoms arranged in a non-repeating units. Okay, so the thing that I have written here wants to tell us that glass is a non-crystalline structure that is formed by the repeating units of SiO2. Okay, so SiO2 forms the glass, but they are arranged in a non-repeating units. Okay, so there is not a proper structure framework present there. Okay, so they are arranged in a haphazard way in a non-repeating unit, so they are called non-crystalline structure. Thereafter, in dentistry there are the polymeric based material which are non-crystalline in its shape. Similarly, the structural arrangement do not represents the low internal energy. Okay, as in a crystalline structure the atoms are arranged in a particular manner, particular form. Okay, so there is a low energy. Okay, low internal energy is present in those type of molecule, but as here in non-crystalline structure there is not such a structural arrangement present, so that there is no low internal energy. Okay, so many different dental materials often consist of non-crystalline structure like non-crystalline glassy matrix. Okay, and crystalline inclusion. So particularly any kind of non-crystalline structure that is okay, mainly that is a dental material. Okay, mainly consist of the two forms. One is non-crystalline glassy matrix. Okay, so matrix is present there which is non-crystalline glassy, and crystalline inclusions are present there that are filler particles in those matrix. Okay, and the function of those crystalline inclusions are color, opacity, increase in a coefficient of thermal expansion and increase in a radio opacity. Okay, so those filler particle gives the properties of color, opacity, increase in coefficient of thermal expansion and radio opacity to that particular dental material. So these points want to tell simply as that any dental material that is non-crystalline in its structure consists mainly two components. One is matrix, another is a filler particle. Matrix, it is a non-crystalline and glassy, and the filler particle there is crystalline inclusions present, and those filler particles are responsible for the color, opacity and increase in the coefficient of thermal expansion and the radio opacity. Okay, so those filler particles provide those properties to that particular dental material. After that we will see about the interatomic bond distance and the thermal energy. So between any two atoms there are the forces of attraction drawing them together and the forces of repulsion between them apart. Okay, so this is a simple theory, general theory. We everyone knows we everyone know it, that when two atoms are closer, okay, so there is a sort of force of attraction between them, also there is a force of repulsion between them, but the equilibrium between those forces helps to keep them in a position. Okay, after that I have written the bond about the bond distance. So bond distance represents the distance between the two atoms at the equilibrium, and the equilibrium means it is a position. Okay, and the equilibrium position of the atom means it is a position at which both the forces are equal in the magnitude but opposite in direction. Okay, so bond distance is simply the distance between the two atoms. Okay, when there is a when they are in a equilibrium position, and equilibrium position is that position when the atoms, okay, when the atoms the force that is acting upon those atoms are equal in magnitude and opposite in direction, means that the force of attraction and the force of repulsion are in equal magnitude but in opposite direction. So at that point it is called equilibrium position, and the distance between the atom in equilibrium position is the bond distance. Okay, so it is easy. After that we will see about the bonding energy. So bonding energy, simply energy or the work means force into displacement. Okay, and the integration of the interatomic forces over the interatomic distance is the interatomic bonding energy. Okay, so it is sort of the integration. Okay, it is the integration of the interatomic force over the interatomic distance. Okay, after so now in the thermal energy, it, any atom, okay, in the crystals at the temperature that is above the absolute zero are in a constant state of the vibration. Okay, and the average amplitude is dependent on the temperature. Okay, so just it is easy to understand anything. Okay, any crystals atom that are above the temperature of the absolute zero have certain constant state of the vibration. Okay, and when we take the average amplitude of those vibration, and it depends on the temperature, okay, on which it is present. Similarly, the higher the temperature, there is greater the amplitude of the vibration, and there is a greater kinetic or the internal energy or the thermal energy too, okay. So these all the topics are of our intermediate level, so it is not important in dental materials, okay. They won't ask you in any kind of theory exams or in the viva exams, but as we are going in a sequential manner, so I thought just make a little video, short video of those topic too, okay. At last I have discussed about the eutectic and peritectic, and I think these are quite important in this chapter, okay. Now in the polymerization section, it is a process of formation of the polymers by the monomer simply, okay. In addition polymer and the condensation polymer, so in addition polymer there is a same number of atom in the monomer and the same number of atom present in the polymer, but in a condensation polymer there is a fewer atoms in the monomer, sorry, in the polymer, but there are higher number of atoms in the monomer, because there is a formation of the byproducts, and that byproduct is taken out, okay, from the formation, taken out from the reaction, okay, so that there is a less or fewer number of atom in the resultant product. So addition polymer, condensation polymer. After that we will see about the addition and the bonding, and in this topic just think many of us may have confusion about this addition and cohesion. So simply understand, addition means the, okay, so I will explain in easy manner. Think this is a water molecule and this is also water molecule, but this is a glass molecule, okay. So the attraction between the water molecule and the glass molecule is called adhesion, but the attraction between the two water molecule is called the cohesion, okay. So the force of attraction between the similar kind of molecule is cohesion, and between the different kind of molecule is called adhesion, okay. After that there is presence of surface and the surface energy. So surface is outermost layer of any kind of object, okay, but surface energy means the energy on the surface per unit area, okay. So the energy that is present on the surface of any kind of object is a surface energy. Also we can define it as a surface tension, okay. So I have written two material and their surface energy respectively. So an enamel, it have 92 millijoule per meter square. In dentin there is 87 millijoule per meter square, okay. So you can remember those data, but they are not so important, but also you can remember, it is easy to remember. In enamel it is 92 and in dentin it is 87. After that we will see about the weighting. In weighting, it is for the adhesion, okay. Liquid must flow easily over the entire surface. This characteristics is known as the weighting, okay. So weighting means simply you guys understand that, okay, for the addition of the two molecule, okay, one molecule, okay, that is adhering to the another molecule should flow properly on that surface, okay. Think that it is adhering to this surface, it is a water molecule and this is a glass molecule, and this water molecule wants to adhere to this glass molecule, so this water molecule should weight this surface of this glass molecule, okay. So that property is called weighting, okay. So weighting is extremely important for the adhesion. Ability to weight the substrate is the dominating contributor to the adhesive bond when the adhesive set from the liquid to solids, okay. So it is explaining that point that I have told you. After that, contact angle of the weighting means angle between the tangent line and the solid surface, okay. So it is angle between the tangent line and the solid surface. So I will show you the picture explaining it. So in this picture, as we can see here, okay, so this red line, okay, so the red line is a tangent line and this green line is the solid surface line, okay. So the angle that is made between this red line and this green line, the theta is there, okay. So that theta angle is called our contact angle of weighting, okay. So here are three examples, okay. So in clean glass plate, okay, so the angle is theta, and acrylic, so contact angle of the distilled water on the three surfaces and the relationship among the interfacial energy. So the water is spread freely on the film cleaned glass slide, okay. Good weighting is there. In clean glass plate there is a good weighting. Similarly in acrylic sheet, when the distilled water is placed, there is a formation of the contact angle of theta 75 degree. Similarly when it is placed on the teflon, theta is 110 degree, okay. And here is a general diagram of this, okay. So I have written contact angle of some important solid and the liquid when it is placed over those solid, okay. So if the solid is amalgam and the probing liquid is a mercury, okay, so when mercury is placed over the amalgam, the contact angle is 145 degree. Similarly when the solid is amalgam and the probing liquid is water, the contact angle is 77 degree. And when the solid is acrylic denser resin and over it when we place the water, then the contact angle is 75, and dental ceramic is the solid, and when the probing liquid is water, then it forms the 71 degree. So you can remember those four data, and those four data are from the Phillips, okay. So we got it. After that in mechanical bonding, so mechanical bonding means the bonding where there is a presence of the when there is adherence between the any two object mechanically, okay, as like in the screw bolts or undercuts, okay, when we fix the screw there is no any such of attraction present, okay, just interlocking force present, there is a mechanical force, okay, mechanically they get adhere, okay. But in dentistry, when we study about the composite, okay, bonding agents, okay, so in those chapter we study about the micromechanical bonding. So micromechanical bonding is present in the composites, okay. So the resin matrix of the composite get penetrated into the paste dentin, okay. So those tags, those resin tags forms the interlocking, those forms the micromechanical bonding. We will discuss it about in our composite chapter, okay. But for now just remember, in resin based dental adhesive there is a micromechanical bonding present. Now in eutectic and peritectic alloy, okay, so eutectic and peritectic alloy sometimes they can ask you in viva, okay. So eutectic alloy means in this alloy, okay, okay, it exhibits the complete solubility in the liquid state but limited solid solubility, okay. So those alloy exhibits the complete solubility in the liquid state, okay. So when they are in liquid state they exhibit the complete solubility but limited solubility in a solid, okay, but limited in a solid solubility, okay. So it solidifies at the single sharp temperature, the eutectic point, okay, and it is used in dentistry in the dental soldiers and the casting alloys, okay. So they are used for the dental soldiers and the casting alloys, and the examples of eutectic alloy are silver copper and the aluminum silicon, okay. So you can remember this. And the reaction of eutectic alloy is liquid, it gets changes into the solid A and the solid B, okay. Okay, so there is a particular sharp temperature, particular temperature at which this reaction takes place, okay, and that temperature is called eutectic point. Similarly the peritectic alloy, in this peritectic alloy there is a presence of the reaction of this peritectic alloy is the liquid plus solid one forms the solid B, okay. And during the cooling, a solid and the liquid combine to form a new solid phase at the peritectic temperature. So it is during the cooling when one solid get react with another solid, okay, one liquid get reacted with another solid forming a different solid, okay. So the example of this peritectic alloy is iron nickel and the copper zinc. You can remember this. And they are not widely used in the dentistry. Limited solid solubility, as here I have discussed, they exhibit the complete solubility in the liquid state but limited solid solubility, okay. So they completely exhibit the solubility in the liquid, okay. So they exhibit complete solubility in the liquid state but limited solid solubility. But here also there is limited solid solubility, okay. And this type of reaction occurs when there is a large temperature difference present between those metals, okay. If the metals have large temperature difference, in such reaction there is a formation of peritectic alloy, okay. So just remember those points, okay. So and the use of eutectic alloy in the dentistry, this will be more than enough for you. So this was for today, and we have completed our boring chapter in this dental material. And in from the next video of the dental material we will be starting with any particular chapter, okay, like dental amalgam or dental cement. Let's see in another video. So if you love this video, please do like, subscribe and share with your batchmates. And also you can follow the Mr. Teeth on Instagram and the Facebook, okay. We have pages on both the platform. And for the notes of those video, okay, you can visit my Telegram channel. So I have kept all the notes of my videos in that channel in proper manner, okay. So I will catch you in the next video. Till then, stay happy, stay healthy. Tata, bye bye, thank you.